Hello, pre-algebra class. Welcome to another episode of Mr. Shouttime. This one comes a little bit later than usual because I did not record it on the weekend like I usually do. But that's okay. Here we are. The real number system. Real numbers. That's what we're doing. Pretty good, right? Okay. Lesson 7, page 174, if you're following along in the book. So, real numbers. Real numbers are just the set of the rational numbers, which we've already learned. Rational numbers are numbers that you can write in the form of a over b, where both a and b are integers, and where b does not equal 0, right? Well, what are irrational numbers? Irrational numbers are just all the numbers that you cannot write as a over b. So, for example, the square root of 2, you cannot write that as an integer of, as a ratio of two integers. So you could write this as square root of 2 over 1, but if you were to try to write the square root of 2, this number would go on and on and on, and it would never repeat. Okay, so you remember when we were able to turn numbers like 0.3 repeating into a fraction? You cannot do that with the square root of 2. Or with pi, or e, or any of these other examples. And there's more. There's more examples than that. Yeah, an irrational number cannot be expressed as a ratio of a over b. So let's take a look at these numbers. Is this a rational number or an irrational number? Or any kind of number. So we'll first start with rational or irrational. And this one is rational because 21 and 7 are both integers. So this is rational. Rational. Is it also an integer? Yes, it is, because 21 divided by 7 is 3. Right? And 3 is an integer. And in fact, it's also a whole number, and it's also a natural number. So if you were asked to name all the sets, then you would say rational, integer, whole, natural. Negative 2.5. This is also a rational number. You could write this as negative 2 and 1/2, which is the same thing as negative 5 over 2. So that's a rational number. Is it an integer? No, it's not. Is it whole, natural? No, it's not. It's only a rational number. And then 0.2 repeating. Yes, this is a rational number. As you hopefully know at this point, any decimal that repeats in a pattern over and over can be written as a rational number. So this is rational. It's not an integer or a whole or natural number. It's just rational. And then here we have the square root of 38. This one is a little bit tough to figure out. So first, we need to see if we can simplify this in any way. At this point, you know that the square root of a number is two numbers that multiply together to get to be that number, right? And so the easiest way to do this would just be to put this into the calculator and see if it has a repeating digit. And I don't believe it does. So calculator, the square root of 38. And look at that. It does not look like it does, right? And in fact, the square root of many numbers is irrational. And so yeah, this is an irrational number. The other way you can do it is seeing if there's any numbers that you can multiply within this. So this is the same thing as the square root of, for example, 2 times What's 38 divided by 2? 19. And the square root of 2 is irrational, and also the square root of 19 is irrational. And you know that because the square root of prime numbers is irrational, and both 2 and 9 are prime numbers. So this is going to be irrational. But you don't need to worry about that. What you could, if you see a square root of a number and it's not a perfect square, then you can usually just assume that it's going to be irrational. Okay. I probably spoke for too long there. Your turn. Welcome back. Okay. This one, I'm just going to use the letters N, W, I, R, and IR. Okay. So this is a rational number. This is a rational, integer, whole, natural. This is rational, and this is rational and an integer. Okay. Comparing real numbers. Here we're just going to fill in the blank with one of these symbols. Greater than, less than, or equal to. So the square root of 15, what is that? Well, the square root of 16 is 4, and the square root of 9 is 3. So this is pretty close to 4, and this is pretty close to 3, right? This you would round down to 3, this you would round up to 4. So this one is bigger. Also, you could just, again, use a calculator and do the square root of 15, and there it is, 3.87. Yes, that's bigger than 3.33, which is what 3 1/3 is. Your turn. Welcome back. All right. So here we have the square root of 64 and the square root of 49. This is somewhere here in the middle. It's actually pretty close to the middle, right? So this is going to be 7 point something, and this is also pretty close to the middle of 7. This is 7.4, right? And so this one I would just use a calculator. Where did it go? Did I close it? Whoops. Oh, the square root of 57, 7.54 versus 7.4. So here we go. Ordering real numbers. So you can choose to do this however you like, but you have to convert them all into the same form, right? So this is in fraction, and then we have 2 roots and then a decimal. And for me, decimal is probably always the easiest. So this is 8.8, and this is 8.3 repeating. And then this is 8. And then this is 8.71. So if you're going to order these, it would be square root of 64, 8.3 repeating, square root of 76, 8 and 4 over 5. And remember to write the numbers like these instead of like these. Do not use the numbers that you've converted, because you're not ordering these, you're ordering these numbers. So you need to give the answer in these numbers. Okay, your turn. Oh, this is 5. This is 5.6 repeating. This is 5.6. And then the square root of 30. I don't know what that is. And I keep closing my calculator on accident. What is it again? 30 is 5.4 7. So this is going to be 15 over 3, square root of 30, 5.6, 5.6 repeating. There's your answer. Okay, solving equations. So here you can see that x squared equals y, right? So let's say x is equal to 3. X squared equals 9, right? Because 3 squared equals 9. So if x squared equals y, then x equals plus or minus the square root of y. What does that mean? Well, let's say that y is 9. So we want to find what x is. Well, we would take the square root of both sides, right? Here's our equation, x squared equals y. And so how do we get, if we're solving for x, how do we get x by itself? We have to take the square root of it, right? If we take the square root of that, then we need to take the square root of this, right? So that is x equals the square root of y. Well, x could be, oops, I didn't mean to do that. X could be 3, but x could also be negative 3, right? If x is 3 or negative 3, x squared, 3 times 3 is 9, negative 3 times negative 3 is still 9. Both the positive and the negative of x will give you a y of 9. So if you have the square root of, I'm sorry, that's not what I meant to do. If you're given the situation where you know that x squared equals y and you're solving for x, and you know that you're told that y is some number like 4, for example, then you would say that x squared is equal to 4. You take the square root of both sides, then the answer would be plus or minus 2. But with a cube root, that is not the case. Because let's say we have the cube root of y equals x. Well, the cube root of y, let's say that y is 27. 27. Well, could x be anything other than 3? X can be 3, right? 3 times 3 times 3 equals 27. But can x be negative 23? No, because if x was negative 3 times negative 3 is positive 9 times negative 3. This is negative 27. So the cube root of negative 27 is negative 3. The cube root of 27 is 3. There's only one answer. And you can use this relationship to solve equations. For example, if I have a squared equals 38, well, what times what equals 38? Let's go to the calculator. 38. So this is going to be 6.164, so on and so forth, right? It's going to be this long, long number. But it could be the positive of that number, or it can be the negative of that number, right? And instead of writing that number, I'm actually just going to write a equals plus or minus the square root of 38. Okay. The cube root of a equals 125. So we would take, the cube of a to the cube equals 125. To solve that, we would take the cube root of both sides. Then a would equal 5. And a can only equal 5. Cannot be -5. Your turn. Okay. So first we would take 3D and we would divide both sides by 3 to get rid of the 3 in front of the D. So we just have D squared left. I'm sorry, it's 3D squared. And on this side, we would have 121. The square root of both sides, that would be plus or minus 11. Here we have 100 equals 4n squared. Divide both sides by 4. That's 25 equals n squared. Square root of both sides. So plus or minus 5. And the last one, 512, the cube root of that. What is that? I think that is it 8? I'm going to guess it's 8. But I honestly cannot remember. Yep, it is. So 8 equals x. So in these two cases, the first two, it's going to be plus or minus. The second case, there's just one answer, 8. Real life. The aspect ratio of a hang glider allows it to glide through the air. The aspect ratio is, so a hang glider is that thing that you can fly on, you know? So the aspect ratio is the surface area squared. The wingspan squared divided by the area of the wing. So the wingspan is this distance across. And then the area is what's inside of this triangle shape. So what is the wingspan of a hang glider if its aspect ratio is 4.5? The aspect ratio is 4.5. The aspect ratio is R. And the area is 50. And we're trying to find S, right? What is the wingspan? And wingspan is S. So S is the wingspan. S equals wingspan. A is the area. And where's the other one? R. Aspect ratio R. So there are our three variables. So we just plug those into the equation and this is what we get, right? So we can multiply both sides by 50. And what is 4.5 times 50? 22. So it's this, not that. So it's 225 equals S squared. And we take the square root of both sides. It's 15. Now, could this be negative? Yes, but does that make any sense? Can the wingspan of anything be a negative number? So the answer is no, of course not. We don't have a negative wingspan here. So it can only be positive 15. I have a feeling it's going to be your turn. And it is. A tsunami. A tsunami is like one of those really big tidal waves. Oh, look at that tsunami. Here's like a beach, and then here's like some people, and they're like, oh no, we're in trouble. So that's a tsunami. A tsunami is caused by an earthquake. an earthquake in the ocean floor. The speed of the tsunami can be measured by the formula s squared, where s is the speed of the wave in meters per second. Meters per second. And d is the depth of the ocean in meters, where the earthquake occurs. What is the speed of the tsunami? What is the speed? That's the question that is asking. What is the speed of the tsunami if an earthquake occurs at a depth of 632 meters, round to the nearest tenth? Go ahead and give that a try. Welcome back. All right, so s squared divided by d, and d is 632, equals 9.61. Multiply both sides by 632. What is that? 9.61 times 632 is 6,073.52. So s squared. So here we multiplied by 632 on both sides. I'm just going to write that. So this is 6,073.52. And then we're going to take the square root of that, right? So that equals 77.9. And we're going to round to the nearest tenth, right? So 77.9. S equals 77.9. And again, can the speed be negative? It cannot. So again, we're only dealing with a positive, 77.9. And our our unit is meters per second. Don't forget about the units, please. And there you have it. Good luck. Have a good night or day.